Hi guys, we're going to go ahead continue our inverse function unit. Today's main takeaway is graphing the inverse. I got a little bit excited and I started to write before I pressed record. Sorry about that. Okay, so before we get to the punchline, let's go ahead quickly review something. In terms of f and then its inverse, so we have that if AB is in the graph of f, then BH is on the graph of f inverse. And the question is, why is that the case? So gentle reminder. So assuming that we have some ordered pair on f, what will be the ordered pair on the inverse? Well, to find the inverse, we're going to go ahead, reverse the order of all the ordered pairs. So in this case, when we switch places, that will give us BA. Okay, so we reverse all the ordered pairs. So on that note, how do we graph the inverse? Well, if you have this in the back of your mind, then this section is not going to be terribly bad. So it says to graph the inverse of a one-to-one function. So it says 1, interchange x and y in a few ordered pairs. Then 2, plot the points from step 1 and sketch the graph of f inverse through them. Okay, that's a lot of words. Okay. Something that I want to remind myself is that the graph of f and the graphs of f and its inverse are going to be reflections of one another across the line y equals x. So let me go ahead and write that. Okay, the graphs of f and f inverse are reflections of each other about y equals x. Cool. And we could have saved all that ink if I had just highlighted what we had talked base in an earlier unit. Okay, so what I'm going to do in order for me to have a better sense, did I really graph the inverse correctly? I'm going to go ahead graph this line. Okay, y equals x. So you can graph it however you want. You can graph by using a slope and y-intercept. I'm just going to do a quick table of values. Okay, so when x is 0, y should equal 0, and then when x is 1, y should equal what? To do the graph of a straight line, all we need to do is locate 2 points. We got our 2 points. So we have 0, 0, namely the origin, and then 1, 1. Okay, so this line is not going to be the graph of f, because the graph of f is the one that's listed right there. It's not going to be the graph of the inverse. But I need it so I can see, are these really inverses of one another? So yeah, I couldn't find my my bookmarker, so I gotta do what I gotta do. Okay. Now, if I try to eyeball it, maybe I could take like this piece and reflect it to the other side. Where am I? Okay. And reflect it about the line y equals x. And then maybe I could take the other piece. And I could take the other piece and reflect it. So I can take this piece and reflect it about this line and something like this. So if I take this green part and I flip it over, it looks like this butterfly right here. And if I take this pink part and reflect it, we take a selfie, it kind of looks like this. Okay, but I don't like to sketch things if I can have a more accurate graph. So with your permission, I'm going to go ahead locate some points that are on the graph of f. Let's go ahead do a table of values. So we have x, y. I'm going to start at where is this point? 4, 0. And if 4, 0 is on f, guess what has to be on the inverse? Yeah, we switch places. 0, 4. And then the next one will be 3, 1. So if 3, 1 is on f, then when we switch places, the 1, 3 should be on the inverse. And the reason being is that's just a cool thing about functions and their inverses. To find the inverse, we're gonna reverse all the ordered pairs. Next one that's highlighted, which one is it? It's 0, 2. So if 0, 2 is in f, when we trade places, 2, 0 will be on the inverse. For the grand finale, where am I? Negative 5, 3, I believe. So if negative 5, 3 is in f, you guessed it, when we trade places, 3, negative 5 should be on the inverse. So let me go ahead start in order. So 0, 4 is on the inverse, so we stay put and then we go up 4. Followed by 1, 3. So 1 to the right, 3 up. followed by 2, 0, 2 right, and then we stay put, and then followed by 3, -5, so 3 right and -5 down. So you guys are much more better artists than I am. I'm gonna do my best to graph this, okay? Make sure if I graph these correctly. I think so. Okay, so I'm gonna rotate my paper so I can have a fighting chance to actually do a nice graph for you. Okay, so let's go ahead. So it looks almost like a straight line, but it's okay. I tried my best. That's all that matters, okay? And if I squint really hard, I want to know. So this is the graph of f, and this is what I claim the graph of the inverse to be. Cool. So if I squint really hard, I want to know, are these graphs reflections of one another about the line y equals x? Yeah, because if I take this part from f and I reflect it, it looks like this piece. And if I take this pink part from f and I reflect it, it looks like that piece. So we totally nailed it. So let me just make sure I answered all the questions. So it says use the graph of the one-to-one function f to sketch the graph of f inverse. So we did that. Cool. But now we have to state the domain and range of f inverse. So you can do this however you like. With your permission, this is how I'm gonna do it. We're gonna go ahead and identify the domain and range of f, and then we'll trade places, and that will be the domain and range of the inverse. So for f, the domain is given by what are all the x values that are used to create the graph. So it looks like it's all the negative values up to, then we go to 4. So it's going to be the interval from -infinity to +4 where 4 is included. So interval from -infinity to 4 where 4 is included. What about the range? So the range are the outputs or the y's, and we go from bottom up. So the lowest value of y, where am I? I think it's at this point. So we're at y equals 0, and then we're going to get all the positive y. So it's going to be from 0 to infinity, where 0 is included. Sorry about that. Cool. So again, to find the inverse, we're just going to reverse the order of all the ordered pairs. So all the x's become the y's, and all the y's become the x's. So the x's, where are they? They are in the domain. The y's, where are they? They are in the range. So if we trade places, that will become the domain and range of the inverse. Okay, so the domain of f becomes the range of the inverse. And on that note, the range of f becomes the domain of the inverse. And oh, sorry, that's like the ugliest infinity ever. Okay. Now, looking at our graph, does this hold true? Okay, when we look at the graph of what we claim to be the inverse function, we have that the domain is given by what are all the x's. So it looks like we start at this point, 0, 4, and we keep going forever. So it's from 0 to infinity. And then for the ranges, the y's, the lowest value is a lie, but we're coming from the negative side. So it's going to be from -infinity up to this y value, from -infinity to 4. Look at that. I'm so proud of you guys. Thanks.